I'm here today to share a little bit about the smart factory and bringing a smart factory to real life in the sheet metal processing industry. There are some specialties. Trumpf is very much focused on sheet metal processing, and I think there are a lot of things to share and also to spark some ideas in this. I'm based in China, and I'm leading also our Center of Competence for Smart Factories in Asia overall. So the examples and use cases I'm sharing today are very much focused on Asia, but I think also very relevant for all other parts of the world. To start with, just a few words about Trumpf. Maybe one or the other has heard a little bit. Trumpf is a family-owned business, almost 100 years old. We are a technology leader both in machine tools for sheet metal processing and then also for laser technology. Very much focused on innovation. So we really want to bring the newest technology and groundbreaking solutions to our customers consistently. And we're present all over the world, 70 subsidiaries. Wherever you can find industry, you can also find Trumpf. Sheet metal is basically everywhere. Just a few numbers to have a rough idea about what the companies looks like. Just about 3.5 billion euros in sales. Maybe 14,500 employees by now. And the R&D quota is something also to point out. Usually in these things, we usually invest 10 to 12%, somewhere in between of our sales into new R&D to actually deliver on this promise for innovation, new technologies, and especially also new solutions. Trumpf has started to commit being a solution provider for our customers 8 years ago, where we say we cannot just sell single machines to our customers, but we have to actually provide a full solution that is fully integrated between different technologies, but also with software systems, with preparation processes and follow-up processes. So this is a very strong focus for us. Traditionally, our machine tool division is providing sheet metal processing machinery along the whole process chain for sheet metal, starting from cutting in two aspects. One is laser cutting, and then CNC punching and punch laser processing. Bending would be the next steps, welding, some other smaller technologies as well. We also have tube processing equipment, and this is what really binds everything together, integrated solutions for networked production that actually integrate all the different process steps, the overarching IT systems, and also the process steps like logistics that happen between the traditional processing. We call this we.CONECT, our smart factory that is integrating basically the whole factory of our customers, which are very much focused on sheet metal processing or have a production area where the sheet metal processing is happening and is then delivering internally to other departments. We have another business division that's focused on laser technology with over 40 different laser sources, also laser systems, mainly employed in the automotive industry, laser marking systems, and RF generators for industrial applications, which we also use internally for our systems, but also sell externally. This is a different focus, not mine today, but also very important for Trumpf as a whole. So going into the smart factory, sheet metal processing is an area where smart manufacturing is really not the first thing many of our customers thought about when all this Industry 4.0 and so on started. Sheet metal processing is a classical case of discrete manufacturing. Depending on the part specialties, the routing between different work steps is very complicated sometimes. So it used to be very much manual driven, also not very automized and digitalized at all. To understand the general process, we usually start with cutting, laser cutting and punching. And then this comes to part separation. So we start with a whole sheet and the parts are cut out of that sheet. And then you need to take them out of the sheet to then be able to process them further, usually by bending. So bringing the part in shape, 3D, 2D to 3D. Then there are some manual work steps possible. For example, adding small screws or threads. So there's a lot of possibilities that need to be done manually. And then welding is an important step also actually in terms of automation. This is a very different, difficult thing to do for very high variety and mostly low lot sizes manufacturing systems. And then after welding, we have following processes like painting and assembly. Sometimes others still, but these are the main things. So cutting, bending, some manual work steps, welding, and then we go into painting and assembly. So just to have a rough idea, I brought some pictures to see what the shop floors look like. These are all Asian pictures, quite down to earth, sometimes very messy. Very manual, and what you see here, there's a lot of work in progress in many of our customers' manufacturing. Here on the left side, you can see that there is a lot of paper, there's a lot of small lot sizes, and handling the parts that run through the production is usually quite cumbersome and troublesome. You see the manual welding processes usually very manual and need very high level of welding expertise then as well. What we see in general is, I think this is a general phenomenon, but for sheet metal, it's the same. We're coming from mass production in the past, several hundred parts, and preparing one job and post-processing one job had a defined time. So you need to prepare the drawings, you need to prepare the programs, you need to do logistics, you need to close the orders and so on. So there is a significant time that needs to go into these indirect processes. This was not a big problem because the lot sizes were big. Right now, what we're seeing is that the lot sizes are drastically reduced, and this is a general idea. But for sheet metal, there is really a high variety of parts. Sometimes it's really lot size 1, and the preparation and post-processing times are really becoming an important thing that customers really need to go into optimization. We did a study with the Fraunhofer Institute in Germany, looking at many of our direct customers, and this study revealed that actually 80% of the production time in sheet metal processing is in indirect processes, and only 20% in direct processing. So in the past, machines were getting faster and more efficient in each individual work step. But to help sheet metal companies to actually prepare for the future of high variability and low lot sizes, really the indirect processes are the real important things to tackle. And Trumpf is doing this with an integrated approach to say we really look at the whole value chain from order incoming, and then of course all the individual process steps, but also of how to connect them and provide solutions that actually fit together for our customers over the whole process chain. This is very important because many of our customers are small and medium-sized companies, and they don't have the team, the capacity, as also the capability to set up a smart factory approach completely by themselves. So what we do is come alongside and help them to do this. Specifically, 3 examples maybe here. One is planning and administration. So, for example, offering a web shop so that customers can automatically upload and communicate and then create an offer online. Planning the production planning is very important to have a flexible system, even in this kind of discrete and many times fast changing environment. Programming is very, very important. Sheet metal processing means that you need to nest the parts on a sheet, and whenever an order is changed, all the nestings are impacted then again, and this needs to be very intelligent to actually be efficient in the production. And shipping after the production, of course, is also very important. Interlogistics is a very big topic, to know which order is at which place and how to get it to the next processing step. So creating the high transparency in interlogistics, supporting warehouse management, set up for machines, which is tools, and also the programs to have them at the machine at the right time. These are all topics that really need very smart solutions to bring our customers forward. And operator organization is the same, getting the right people to the right places, getting the information that they need for each individual job in the time when they need it. Part sorting here, there is also assisted, sometimes automated, but if you cannot automate a process step, assistance is, of course, also very, very important. Now, Trumpf is doing this. We have over 1,800 automated and digitalized sheet metal systems. We have 50 something smart factories coming into operation every year, which is really like a smart factory. It's not just one process step or a part of the factory. And we have a strong team that actually supports the customer from the beginning to the end. Connection of machines is also a very important topic. So all of our machines are connected to cloud systems so that we can provide information to the machine and also get feedback for the job afterwards for further processing and also for statistics. Now, how does this look like? Classical project approach. We start with analysis that really looks into where does the customer stand. We especially analyze the indirect processes with them. Direct processes, of course, have to be designed as well. Then we look into their parts and decide together what technology fits which product. And then put a smart factory approach together to actually fit the specific parts and also the part mix over time. Many of our customers are very, very flexible in which parts they produce over time. So then the system also needs to be very flexible. And then we define a roadmap together so that the customer has an approach to implementation over usually a number of years, and step by step go forward with this smart manufacturing approach. Second step is planning. Actually defining this the production system and material and information flow, fixing the layout, and also planning the implementation phase. During the implementation phase, then we do the project management, work with the customer teams. Sometimes customers also have other parts, and really integrate the whole system together, and support them all through the implementation phase. And then afterwards, because this is also very crucial to actually get the wheels on the ground, is to stay with the customer and help them for long-term sustainable development, which means directly supporting their production. Also means that we continue with our consulting teams to do optimization, many times lean, actually implementing new processes, implementing shop floor management, and actually stay as a discussion and sparings partner for the customer at this point. This is a slide that our Smart Factory consulting team, which is a separate team that actually is not focused on selling machines, but is focused on actually being a partner for the customer for implementation. And where we start with is usually is machine utilization, because this is where the money comes from, which has a lot to do with monitoring. It has a lot to do with setup times and so on and so forth. Many times then automation comes in, because many of our customers are, as this was stated, not automated, or very, very little automated at the current point in time, especially in Asia, but also in other markets. Value stream optimization and actually optimization of the layouts in the production areas, production system management with IT tools and systems. Paperless production in many cases is also a topic, because handling production papers is a headache for many of our customers. And then connected logistics, not just automated logistics, but also AGV approaches, for example, but also supported logistics that can create transparency over logistics orders and where to bring what material at what time. And at the end, we hope to actually connect all the processes for the customer, so that there is full transparency. What is supporting these things is shop floor management, and at least in part, digitalizing shop floor management. Not everything is necessary or good to digitalize, but of course the data that you have needs to be on the shop floor and be available for immediate shop floor decisions. So we put these concepts together, and continuous improvement, just as traditionally lean, or the lean aspects are coming into all of these projects, because bad processes, automated or digitalized, are still bad processes, and the customer will not be happy afterwards. Now, I have a video to have a rough idea of what sheet metal smart factory can look like, and we can look at this. I hope there is sound. If there is no sound, or the sound is too big, then we might need to adjust a little bit, but let's try.
So there was sound at the beginning, but now it's stopped.
So what we usually have is the process steps in an automated system are connected with a high rack warehouse. So this is automated storage, but also a logistics center that automatically provides the raw material and also manages the process parts. And then an overarching IT system that is covering MES, that is covering WMS, is covering the programming, and also the logistics management and monitoring and statistical analysis. the process usually starts from a full assembly that is taken apart into individual parts and then programmed, nested on a sheet, and then sent to the machines directly via the company network. And the machines can order the material directly from the warehouse and start the processing. Here we have an automated punching machine. We also have customers who have half automated or manual processes, but these can also be integrated in this kind of system. Now, when the cutting is ready, usually the parts go back into the storage to have them ready for the next processing step. In this case, what we see here is an automated bending cell that is also then fully, there is no manual interaction, fully processing the bending step in the process line. Robot bending, Trumpf is very strong on machine integration there. And then the parts are ready and can be taken away either by a manual forklift or some transport device, or also integrated directly with an AGV system. We work together with Jungheinrich to actually provide an integrated system between machines and automation, and then also the AGVs that transfer information and also then trigger the following process steps once the parts and the orders are ready. Transparency of what is where and what each machine is doing is, of course, very important. And all of this is integrated by our IT system, which is called Trumpf's FAB, integrated production system. Just as a rough idea of how this can look like, and now I have two examples from customers in China where we did smart factory transformations. Two of many in China and also in Asia, in Europe and the US. There's many more, but this gives an impression. So this customer is producing electric cabinets, big company, large scale of production, and we came in because they had a very high complexity in shop floor management. Also, they're lacking skilled workers, which is more and more becoming a problem in China. And in-plant logistics were not efficient, and they didn't have much transparency in their production information. Then the solution we provided was partly automation. So similar to what we just saw in the video, an automated high-rack warehouse that is really the logistics system or the center of material management in this system, and then punching and automated bending centers. Automated programming with Trumpf's Boost that is integrated directly with the machines and also with the automation, and then production management, meaning MES and also WMS with our Trumpf's FAB, which is also then integrated completely with the machines and the other processes. The customer reduced their manpower for a similar production range from 12 to 3 people. So actually quite big improvement in terms of management and having to find the right people. Production area was also improved, transparency, and then the order management system is much simpler now for them to actually have an overview of which order is where and when they can expect it to be ready and be shipped at the end. Few pictures. Left side is before we started the project. We can see there is a lot of work in process, and even finding raw material is a problem in this kind of setting, which then leads to a lot of waiting times and machines being idle, etc., and so on. On the right side, you see the new factory. There's 2 systems now that they use for different products. And they have a nice new factory, but only the new factory wouldn't have done it. The processes behind are the most important thing. What you see is there is no paper. there is no material that is lying around. Everything is nicely in the systems and can be found directly on the press of a button. So this is a customer example. The software system, I forgot this, integrated from the beginning. Incoming order in this case is an interface to the overarching group ERP system where the orders come in. Then we create the production orders and do the scheduling. Programming is the first processing step, really. And then resource allocation, inventory management is directly connected to that. Production and production order management over the whole process. Production control in terms of is everything going well? Are all the machines running? And how do we make process monitoring the whole process? And then post-calculation also to determine efficiency and possible improvement areas all in one system. And this is very important to actually integrate all these different steps and not jump back and forth from different systems. Okay, second example is actually our most important and most critical customer, which is the Trumpf internal sheet metal manufacturing unit, which is the testing ground for all of our technology. If they are not convinced by the products that we provide, we usually know that we have to do something different. Taizang, Trumpf Taizang sheet metal products, they work for Trumpf. They also work for external customers as a job shop. For example, Heidelberger, Siemens, KUKA, and so on, to provide sheet metal parts. And they had a big problem with bottlenecks, both in bending and for welding. For the area that they have, the number of machines, they knew that there was still potential in there, but they couldn't get it out. Searching times between work steps because it wasn't clear which job was already done, where the material was, and so on. Planning because data reliability of actual processing data was not available. Also very space limited in the existing factory, and production information not at the places where we needed them. And what we did is we also introduced automation for them, not for all of the machines, because not for all of the machines it made sense in terms of changing between different jobs and so on. So very targeted. We took out all the paper from the production step by step, digitalized all the drawings, all the order paperwork is now channeled through the system, and with a few helping points, tools on the pallets that go through the production. Introduced digital shop floor management for them, also automated programming, our production management system, and gradually we're still working on this and will work for probably the next 10 years to step by step really further improve the processes. Then smart logistics system, including AGV transports, that also then automatically connect some of the process steps, and had really good benefits out of that. Machine utilization was increased from 55% on average to 75% on average, which is really a lot of money to take out of this existing production. Output, of course, then was also increased. The same team, because we automated some of the machines. We reduced the production area by actually 20% to make room for additional value-adding steps. And transparency and on-time delivery also was greatly improved by this project. Little bit more specific, a few pictures here. On the left side, we see the fully manual production with a lot of in-process material here as well. And not very streamlined logistics processes. On the right side, you can also see the warehouse and part of the machines that are automated now. The screen, the monitor you can see in this lower picture is really the production data right at the machines. We monitor and bring that also to the operators to work on a running basis with the data, and then also the AGV system that is connecting the bending processes with our quality check processes. Paperless production looked like this in the past. So a lot of sheets and forms to be filled out, to be printed, to be taken to different process steps, always on the pallets and production carts. And now it is all in the system. All of this information is available at each work step, and the operators can bring out all the drawings, all the technical data they need for the individual processing step. So all at the point, at the time, at the order where they need it, it's available in the system, and there is not much room for making mistakes or needing to find the right parts or the right order, or even losing one of the papers and then not knowing what this is at all anymore. Then machine utilization. I think this was probably the biggest improvement here, coming from 55%, which is a very good number already in sheet metal processing. Many of our customers are far below that. And we mainly introduced 5 measures. One is automation or targeted automation for some of the machines. Then machine status transparency. This is a tool that we also offer to our customers, co-developed with Siemens based on the Siemens MindSphere, that creates machine transparency and also gives feedback to the customer of when in the process there were some problems that need to be solved in further processing steps. Smart programming with the possibility to actually model and simulate the bending process especially. And then clear lean topic, optimization of setup times, organizing the tools and parallelizing the setup process to the actual processing of the sheet metal parts. And all of this actually brought very, very good results here in machine utilization. So that's for now. I think we have a few minutes. No, I'm actually over time already. Sorry. Thank you very much.
Okay, thank you very much for your presentation. And like Sonja just said, we're a little over time already. So if you have any further questions, just contact her via the app or LinkedIn. And thank you for your presentation. And I think good night, as you're a little ahead of our time.